Okay, picture this. You've got this huge asteroid hurtling through space. And at first, everyone's pretty worried, right? It looks like it might be on a direct path for Earth.
Classic scenario.
But then, the scientists crunch more numbers, get better observations, and phew, relief. It's not going to hit Earth.
Right. The direct threat evaporates.
But hold on, because here's the twist. The threat didn't vanish entirely. It sort of changed its cosmic address, set its sights on our nearest neighbor instead.
Exactly. And that's the story we're diving into today, focusing on Asteroid 2024 YR4. The latest research isn't about an Earth impact anymore. It's about this potential collision with the moon, maybe in 2032.
Right, and not just the impact itself, but what that could actually mean, downstream for us back here on Earth.
Precisely. The ripple effects.
So our mission today is to unpack all that. We're digging into the science, the probabilities. We're drawing heavily from a recent Science Alert piece that flagged this pretty surprising turn of events.
Yeah, it really caught people's attention.
We want to explore what it could mean for you listening right now. Balance the, wow factor of a potential cosmic event with some real worries about our tech up there. So let's get into it.
Let's do it.
Okay, so rewind to earlier this year, 2024 YR4. It definitely caused a bit of a stir.
Oh, for sure.
For a little while, this rock, what was it, 60 meters wide? About 200 feet.
Yeah, that's the one. Definitely big enough to earn that city killer tag if it were to hit a populated area.
And it was given, a 3.1% chance of hitting Earth on December 22, 2032, which apparently was the highest probability ever measured for an asteroid that big.
Yeah, that number really stood out. It caused quite a buzz in the planetary defense world, and rightly so.
But then, as we said, more observations came in, better telescopes looked at it.
And thankfully, they could definitively rule out that Earth impact scenario, which is, excellent news.
Absolutely.
But here's where it gets fascinating. Data from the James Webb Space Telescope, this was back in May, showed something else. The odds of it hitting the moon instead, they actually went up.
Seriously?
Yeah, up to 4.3%. So the risk didn't just vanish into thin air. It effectively, it repositioned itself onto the moon.
Wow. Okay, so if it does hit the moon, what are we talking about scale-wise?
We're talking about something truly immense. Paul Weigert, he's the lead author on the study from Canada's University of Western Ontario.
Right.
He estimates it would be the largest asteroid impact on the moon in something like 5,000 years.
5,000 years. That's biblical times almost. A huge event.
Huge. The energy involved, Weigert compares it to a large nuclear explosion. It's staggering.
Whoa.
And their simulations suggest, get this, up to 100 million kilograms, that's 220 million pounds of lunar material could be blasted off the surface.
100 million kilograms. That's hard to even picture, just ejected into space.
Exactly. Think about the sheer force needed for that.
Yeah.
And then you have to ask, where does all that stuff go?
Okay, yeah, that's my first thought. Does any of that debris actually pose a risk down here? Could it, rain down on Earth?
That's the critical question. So the study looked at that. If the impact happens on the side of the moon facing us, which is, roughly a 50-50 chance,
Okay.
then maybe up to 10% of that ejected material could get pulled in by Earth's gravity over the next few days.
10% of 100 million kilograms. That still sounds like a lot.
It is a lot of pieces, but thankfully, they'd mostly be small, think millimeter to centimeter size. Our atmosphere is actually a fantastic shield against stuff that size. They'd burn up.
Oh, so we see them as meteors.
Exactly. But here's the catch. What about everything above the atmosphere?
Yeah.
We have thousands and thousands of satellites up there.
Right, our orbital infrastructure.
And as Weigert points out, a tiny rock, maybe just a centimeter across, but traveling at tens of thousands of meters per second, that's basically like a bullet.
Ooh. Yeah, that doesn't sound good for a satellite.
Not at all. And the study estimates that in the days after a potential lunar impact, the number of these tiny, fast-moving meteoroids threatening satellites could spike, like more than 1,000 times the normal background level.
1,000 times. That's a huge increase in risk.
It really is. And then you have to factor in how many more satellites we expect to have up there by 2032. Tens of thousands more, potentially.
Right, with all the constellations going up, Starlink, OneWeb, all the others.
Exactly. So suddenly, this seemingly distant event on the moon creates a very real systemic risk for all that technology we increasingly rely on. Communications, GPS, weather forecasting.
It really drives home how connected things are, doesn't it? An asteroid hits the moon, and suddenly my phone signal could be at risk.
It's a perfect example of those kinds of ripple effects.
Okay, but amidst all the doom and gloom for satellites, you mentioned meteors. For us on the ground, assuming we're safe from the debris itself, would it look cool?
Ah, yes. The silver lining, perhaps. The study does predict it would be quite the show. A spectacular meteor shower potentially lighting up the night sky.
Huh. Imagine that. Stepping outside, seeing this amazing light show, maybe not even realizing it's linked to this potential hazard unfolding way above your head.
It's a strange dichotomy, isn't it? Cosmic beauty and potential technological peril, all from the same event.
So let's just level set on the odds again. What's the actual chance of this near-side moon impact happening right now?
Right. Important to stress this. Wiegert emphasizes the probability of a direct hit on the near side of the moon, the side facing us, which is the scenario causing the satellite debris concern that remains low. Just 2% currently.
2%. Okay. So not likely, but definitely not zero. It's a non-negligible risk, as they say.
Exactly. Low probability, but potentially high impact if it did happen.
And we can't just get a better look right now, can we? We have to wait.
Unfortunately, yeah. The asteroid isn't expected to be easily visible again with telescopes until 2028.
Oh.
So for the next few years, the world just has to wait for more data to really pin down that trajectory and refine those probabilities. It's a bit of a cosmic waiting game.
Okay. But say the data in 2028 or later starts looking more worrying. Is there anything we could actually do about it? Could we stop it?
That's the optimistic part. Wiegert seems to think so. He believes that if a direct hit does eventually look likely, we probably have enough lead time, years, to plan and potentially execute a mission to nudge it off course, spare the moon.
A deflection mission.
Yeah, he says he's sure it will be considered. It speaks volumes about how far planetary defense has come.
That immediately makes me think of DART, NASA's mission a couple of years back.
The perfect comparison. It's quite relevant here.
How does 2024 YR4 stack up against Dimorphos, the asteroid DART hit?
Interestingly, 2024 YR4 is actually smaller, about half as wide, and maybe only 10% of the mass of Dimorphos.
Oh, really? So, in theory, it should be easier to move.
In theory, yes.
Yeah.
The DART mission was a huge success, right? It proved we can hit an asteroid and change its path using what's called a kinetic impactor, basically crashing a spacecraft into it.
Right. A historic moment.
Absolutely. So if YR4 is found to be on a collision course with the moon, Wiegert suggests it would be a good target for another test, another application of that DART technology.
Okay, so we have the tech, potentially, but are there any, added complications?
Well, there's one potential wrinkle Wiegert mentioned. Trying to deflect something that's going to pass relatively close to the Earth-Moon system. It could be a bit dangerous, as he put it.
Dangerous how? Like we might accidentally nudge it towards Earth?
That's the concern. You're dealing with precise orbital mechanics. A nudge has to be calculated perfectly. Pushing it away from the moon is one thing, but you have to be absolutely sure you're not inadvertently creating a different problem closer to home. It's a delicate orbital dance.
Right. High stakes. Okay, and just quickly, the study itself, where does it stand in the scientific process?
Good point. It's currently what's called a preprint study. It was posted on the RCEIV database. It's a common platform for physics and astronomy papers just last week.
So not peer-reviewed yet?
Not yet, but it has been submitted to a major journal, the Astrophysical Journal Letters, for that formal peer review process. So the wider scientific community is digging into the details now. Got it. Okay, so let's wrap this up. What's the main takeaway here? We started this deep dive talking about an asteroid initially feared for hitting Earth. And we've landed on this much more, nuanced picture. A low chance, yes, but a real potential indirect threat, mainly to our satellites orbiting Earth.
Exactly. It shifted from this direct, dramatic impact fear to a more subtle, systemic risk focused on our space infrastructure.
And potentially quite the light show for us on the ground, if it does happen.
Right. That strange mix again. But I think what's really significant about this research, even with the low odds, is how it highlights interconnectedness.
Yeah.
How a seemingly distant cosmic event, an asteroid hitting the moon, could have these tangible downstream consequences for technology woven into our daily lives. Satellites are critical now.
They really are, from GPS to weather, finance, communications.
Everything. It's a powerful reminder that as our footprint in space grows, so does our vulnerability in ways we might not always anticipate. We have more assets up there to protect. Which leaves you, our listener, with something to chew on. A final thought. Beyond the obvious threat of a direct asteroid hit on Earth, what other, maybe unseen, vulnerabilities exist in our increasingly space-dependent world?
Good question.
How might these low-probability but potentially high-impact events like this moonstrike scenario force us to think differently about our cosmic neighborhood? And maybe start preparing for scenarios we haven't even fully wrapped our heads around yet?
Yeah, something to definitely mull over next time you look up at the moon.
Okay, picture this. You've got this huge